In this video, we're going to look at an example using the SAS postulate. And so in this example, it says to find the value of y that makes the triangles WXY and WXZ congruent. So here below you can see that I highlighted triangles WXY and WXZ with colors, where in pink I have the triangle WXY and in yellow I have the triangle WXZ. So before I start trying to find the value of y, what I'm going to do is try to find sides of these triangles that are congruent to each other. And so the first thing I notice is that these two triangles share a common side of WX, right? So this side here going from point W to point X, they both have this side, and so that means that one side of my triangle in pink is congruent to one side of my triangle in yellow. And so we use this notation of a tick mark, right, to denote that these two sides are congruent. Okay, so now I want to try and somehow find another side length, or another side from triangle pink that is congruent to a side in the triangle in yellow. And so what I notice here is that I have this side length here from y to x that's 19, and then this side length from x to z that's denoted with this expression 3y plus 7. And so if I want these two sides to be congruent, then what I'm going to do is set 19 equal to 3y plus 7 and then solve for y. And then when I plug it back in that y value, I'll see that these two side lengths are the same. In other words, these two sides are congruent. Okay, so I'm going to set to make these two triangles congruent. I need side xy to be congruent to side xz, yx to be congruent to xz. And so what I have here is that I need to solve for y. Okay, so if I need to make these two triangles congruent, right, I need to somehow use the SAS postulate. And so far we had one side lengths that are one set of sides that were congruent, right? But I need two sides of these triangles to be congruent. So to get the second side, I'm going to say that I need to make side yx be congruent to side xz by finding a y value such that when I plug it in, I get that my side length for xz is 19, right? So in other words, I need to set 19 equal to 3y plus 7 and solve for y. Okay, so when I do that, I get 19 is equal to 3y plus 7, and so I'm going to subtract 7 from both sides. I get that this is 12 is equal to 3y plus 0. And so in other words, I get 12 is equal to 3y. Now to isolate y, I need to divide both sides by 3. And so I get that y is equal to 4. Okay, and so I'm just going to make a note down here. We notice when y is equal to 4, xz is equal to 3 times 4 plus 7, which is equal to 12 plus 7, which is equal to 19. And so we have that yx is congruent to xc. Okay. But I also need not just two sides to be congruent, but I also need the included angles to be congruent. Okay, so here, if you look, I see that I have a right angle here for WXZ, which means that that angle measurement is 90 degrees. So if I want to be able to use SAS to say that these two triangles are congruent, then I need angle WXY to also be 90 degrees. So in other words, I need this angle measurement being represented by this expression 20y plus 10 to be equal to 90 degrees. Now coincidentally, we already found what y was. We said that y was equal to 4, right? And so I just need to check and make sure that when I plug in 4 into that expression, I get 90. So I'm just going to write here now we need to check and make sure that when y is equal to 4, angle WXY is equal to 90 degrees. Since 20 times 4 plus 10 is equal to 80 plus 10, which is equal to 90, then angle WXY is congruent to angle WXZ. Okay. And so that means then that when y is equal to 4, by the SAS postulate, these triangles are congruent. So thus, when y is equal to 4,